Hello and welcome to my YouTube channel. This is Dramani Online Mathematics. Please, today try to subscribe if you have not done so, and also make sure that you tell your friend to also subscribe to push this page. Okay, now we are going to look at another method of solving the first order linear differential equation, and that method is the integrating factors. When I started, I told you that you'll be looking at two methods. Method of undetermined coefficient, that's what we just used. Then we are going to use the integrating factors to do it. Now, for the integrating factors, you are familiar with it because when we were doing the exact, we came across the integrating factors. Now, when you look at this is the standard form, right? So if you are using the integration factor, this was the formula that we proved from the exact. We have this formula. Now, here too, if you want to get your general solution, this is the formula. So this formula, you have to put it here. It's unlike the undetermined coefficient formula that I wasn't using, and I was going straight to the point. Here, you need to put this formula here. Okay, remember this C here is not part of the integral. It's outside the integral. Is that okay? And this is the integration factor multiplying by this, or divided by the integration factor, and you have to integrate the whole of this before. Is that okay? Thank you. So now let's look at an example how we apply these formulas to solve those examples. Okay, so this is our first example. The question says we should solve this one using the integration factor or by finding the integration factor. So here we are not using the undetermined coefficient. We want to use the integration factor. But if you look at this very well, when we were dealing with the undetermined coefficient, this one was the same question that we solved. So I haven't changed the question, meaning that when we solve this one, we have to get the same answer as the first one, meaning that if you use the undetermined coefficient, the method of undetermined coefficient, or someone use the integration factor, you all get the same answer. So it's not restricted for you to use the undetermined or the integration factor. So now let's see. First thing, so the first thing to do here is write this one in a standard form. Good. Secondly, identify your P of x and K of x. So P of x is negative 2 over x, and K of x is x over 2. Now that we are done, let's write the formula for the integrating factor. So we say mu is equals to E integral of P of x dx. So mu equals E integral of P of x is negative 2 over x dx. So mu is equals to, when we do this, you are going to have negative 2 e to the power negative 2 ln x, because it's a function in derivative. I hope you can see that. So mu equals e ln x point negative 2. So this e will cancel this ln. So our mu becomes x exponent negative 2, which is the same as 1 over s squared. So this becomes our integrating factor. Is that okay? So the integration factor is 1 over x squared, then the x plus c, all divided by 1 over x squared. So now let's see what we can do. This x will cancel this x. So we have y of x equals, and I can bring half out to have half integral of so this is what we have. Okay, so looking at this, y of x equals half, if you integrate, you have ln x plus c, all divided by 1 over x squared. So this s squared, 1 over s squared, can come and multiply this one. That will give us this equals half s squared ln x plus cx squared. Because this one too will go here. Now compare this one to the first one answer. You will see that they are the same. Is that okay? You will see that they are the same. Okay. Okay, so guys, this is the last try work. This one already I've used the method of undetermined coefficient to solve this, right? So use the integration factor to compare the answer whether it will be the same. And here use the method of undetermined coefficient, then integrating factor to also do this whether you get the same answer for both. Thank you very much for watching. Please, I beg you, try to subscribe and share to your colleagues to push this channel. Thank you very much.